Okay, Math 9, here it comes a video on squares and square roots. So I'm hoping this is a review, but it may not. So what does it mean to be a perfect square? Well, think about the shape perfect square. It means both sides are the same length, which means the area of the square, length times width, is just length times length in this case, because they're the same. So the area is 4. So a perfect square represents the areas of all perfect squares. So as your side lengths increase, but your side lengths are the same. So 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, etc. These are all perfect squares. So what are their products? 1, 4, 9, 16, 25. If we keep going, we get 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. Those are perfect squares because they all have two identical factors. Okay? That is a perfect square. They have two identical factors. So you can factor potential perfect squares into primes if you're unsure. So look at the number 144. Now, some people might be like, Herlaar, I know that one. It's 12 times 12. And there you go, two identical factors. But if you didn't know that and you broke this down, well, you might say, I can divide this by 2. 2 goes into 14 7 times, 2 goes into 4 twice. And then, oh, well, that's 8 times 9, which is 2 times 4, which is 2 times 2. And that's 3 times 3. So if you look at this, you have 2 times 2 times 2 times 2 times 3 times 3. Great, you got a bunch of primes. Can you put those into two groups that are the same? And it's like, okay, well, I can put a 2 there and a 2 there. That gets rid of those. Put a 2 there and a 2 there. That gets rid of those. I can put a 3 there and a 3 there. So technically, you've made two even groups. And if you're multiplying those together, you have two identical factors. But just what are those factors? 2 times 2 times 3 is 12 and 12. So it means that you have two of them. So it means the square root of 144, which we'll get to in a minute, is 12 because you have two identical factors. So if you can make two groups where eventually you end up with the same factor, you're good to go. So let's look at that with respect to square rooting. You see, you channel your inner two become one here because if you're square rooting, if you think about 36, well, 36 is 6 times 6. So it means that the square root of 36 is the square root of 6 times 6. If you get two identical factors underneath here, you have a square root. It comes out as 1. 144 is 12 times 12. If you have two identical factors underneath here, it comes out as 1. This is going to be a theme you're going to see coming forward as well. Now, 256 you might be a little bit hesitant with. Well, then let's factor this. 256 divided by 2 is 128. Divided by 2 is 64. Now, you don't have to break this all the way down because, look, 64 you might know is 8 times 8. And if you think about the fact that you're trying to just get two groups, you have a 2 and a 2 and an 8 and an 8, which means you have 16 and 16. So it means the square root of 256 is the square root of 16 times 16. You have two identical factors, so the square root is just 16. So this is just a quick video. We have a full E lesson on squares and square roots, and then we're going to see them again when we get into Pythagorean theorem. But you need two identical factors to be a square root. That is the whole gist of this thing. And if you have 2 on the inside, it means that as 1 is the square root. A lot of times people say, oh, the square root of 36 is 6 squared, but it isn't because 6 squared is 36, right? The fact that you have two sixes makes the square root just 1 6. So be careful there. Don't hesitate to ask questions, but we are making progress. Thanks so much.